Hi, we're Group 2 from Senior Design Fall 2010. Our project is Infant Vitals Monitor. My name is Anastasia Pavlovic.
My name is Jeff Spangler.
Zach Childers.
I'm Clayton Winter.
And I'm Sam Romano, filming.
We're going to talk a little bit about the objective of our project. Basically, we wanted to come up with a smart vitals monitor that would listen to several of an infant's vital signs, namely respiration, temperature, and pulse, and wirelessly transmit them to a receiver. Jeff and Zach will talk a little bit about the hardware that we use to implement this project.
The temperature sensor that's in here is up through the vest underneath your arm, which calculates the temperature. The technology used there is thermistor. Once the temperature increases, the resistance decreases. It shows you a temperature value for that. And what we did for that is just use a voltage divider down here on the side, right here. So as the temperature is increasing, the resistance will decrease and more voltage, and it shows that on the computer. And the other temperature sensor we got in there is the pulse. Jeff will tell you about that.
What we did for the pulse section is we have battery packs on the back of that actually powering this whole circuit here. And all that's used there are 4 AA batteries. And over here we have the ground. And the pulse is actually connected, the output, to this mote here, connected to ground as well as the power supply, and connected to the finger and measures the oxygen in the blood flow, and will output that as a signal onto the screen. And then for the third one, the respiratory strap, however, that is not functioning, but the circuit will briefly describe what we did to get it to work before. Is down here, and what we used is this little thing here is an op amp, an operational amplifier that was used to amplify the signal, and that had a gain of 10, so that made it much more clear and reduced the noise that was outputted onto the oscilloscope.
The respiratory strap was broken about a week ago, and so for the expo we decided to not include it in the demonstration since the signal wasn't very accurate. But here you can see the respiratory waveform. This is what we had pre-broken strap, so it actually shows our output pretty good there. Now let's talk a little bit about the wireless transmission. Sam, you can go ahead and explain that, and I'll take it.
Essentially, what we used as a microcontroller and for our wireless transmission is a mote. And we actually use 3 motes. The one plugged into the computer runs a program called Base Station on it, which listens to the channel. Anything within the wireless frequency will be received by the mote. The other 2 motes are listening to the sensors that are connected to the body, and they are wirelessly transmitting a digital signal that's actually being sampled from the vital signs. What they are transmitting is being received by the mote and is being dumped onto the serial port of the computer, which is then being plotted by the screen. As you can see right here, this up top is the pulse, and down here is the temperature, which is a steady line because the temperature is steady, whereas the pulse is oscillating.
I'm going to zoom in there and I'll try to hold it still. Let's get a good signal to display. What's it missing? I don't know. That's alright. Clay, do you want to talk about the software some?
Yeah. The motes are actually running programs written in C, and this GUI here that's running the oscilloscope and displaying the actual temperature values and the beats per minute is all programmed in Java. There's actually a Visual Basic program that is a quick run of the oscilloscope programs. Just click on those buttons and it'll pop right up.
If you want to close out and just click each button really quickly.
So I just close the pulse and I'll open it up. There it is.
Sort of.
Yeah, it's
Not working as great as it was before.
yeah, it's getting a weak signal.
And then also we calculate beats per minute up here, which isn't accurate since
There,
it's
the
not,
pulse is
there's
working.
The pulse. All right.
Sometimes it takes a few minutes for the pulse to be read from the finger.
And then also taking a current temperature.
Those temperature readings are in real time.
Yeah, so not only does it show the line on the oscilloscope, over here, if you check in the window, it's actually printing a value, which are being taken in real time. So right now her current temperature is 92, because it's not actually core body temperature, because it's just under her arm. So,
and basically some of the things that we would work on to improve this project are obviously the scale. We would want to make it so that it fit an actual baby and not be so big. Some of the things we talked about doing for that are getting a printed circuit board, which would be tiny, and basically you just send away, build your circuit, and they send you back a tiny printed circuit, and you solder all your connections. We didn't really have time to do that with this project, but that would be one of the main things that we could work on. Also, if we drop some of the packets being transmitted wirelessly, our range and distance of wireless transmission would increase by a lot, so that would definitely improve the project. Also, obviously you're not going to want to have an outward sensor like this, so you would change something, get a more core, I think, so that it wouldn't be as easy for obviously the baby to get tangled up in there. So those are some of the things that we wanted to do. Yeah, that's a good waveform now. Anything else you guys want to include?
Sounds like it.
All right, well, thanks for watching our presentation.
goodbye.